Okay, good day everyone. Welcome to Decision. We're going to start with chapter 1, and this is kindly produced by Dr. Frost and Andrew Blackett. So thank you very much. So what we're going to do is we're going to look at 7 different chapters. We're going to look at what algorithms are, graphs and networks, algorithms on graphs, route inspection, traveling salesman, linear programming, and critical path analysis. Really nice and easy. Okay, so you need to know what an algorithm is. Now, an algorithm is a specific set of instructions for carrying out different types of procedures. And different types of algorithms and specific algorithms have a specific name, method, or a procedure, okay? And basically what we're doing to apply an algorithm to an input and obtain an output, what we're actually doing is computation. The most easiest real-world problem is Google Maps, SatNav, also social media. When you think about TikTok and the algorithms they use to get you on the For You page, okay? All kinds of stuff like that. So, using and understanding algorithms. They can either be in code, Python, so those of you in the class that do computing, I know that you'll know about this, or they can be in flowcharts, okay? So I just want you all to take a minute to see if you are a horse. Okay, sorry everyone, nobody told me I was recording. I have a few people I'm going to blame. First name beginning with J, last name beginning with P. But anyway, when we used 18 here, we did 1 squared plus 8 squared is 65. We then squared separate digits. We keep going until we get 1 or a cycle. We kept going with 18, and what we found was we then got to 1 squared plus 6 squared equals 37, which is what we had earlier. So then, if we carry on from here, we're going to get stuck in the cycle from this number. So imagine it's like having a number, a recurring decimal. So this is our first 2 digits, shall we say, and then our decimal starts at the 37 all the way, and you know it then repeats itself again back to 37, etc. So to prove 70 is happy, 7 squared plus 0 squared 49, 4 squared plus 9 squared 97, 9 squared plus 7 squared 130, 1 squared plus 3 squared plus 0 squared 10, 1 squared plus 0 squared is 1. Stop. Please make sure you write stop, and then, therefore, 70 is happy because we got to the number 1. Here, 18 is unhappy. So, sometimes we have to use what's called a trace table, and here we have our trace table. So, let's get a nice colour pen. Number 1. So, step 1, we're going to write step 1. Let n equal 1, a equal 1, b equal 1. Brilliant. Step 2, write down a and b. Okay, so first of all, this is like step 1 and 2 because I had to write it down, okay? So I'm writing step 1 and 2 there. Then it says, write down, oh no, actually, sorry. No, step 1. Brilliant. Right, step 2, write down a and b. So this is our write down column. So a equals 1, b equals 1. Okay, step 3. Let c equal a plus b. So c equals a plus b. 1 plus 1 equals 2. Step 4. Write down c. c equals 1. Step 5. Let n equal n plus 1. So now this equals 2. A equals b. Now we have to look at what we outputted earlier. So if a equals b, we now have 1, and b equals c. Sorry guys, typo, that should have been 2. And let b equal c. c is 2. There we go. If n is less than 5, go to step 3. n is less than 5, isn't it? Okay, so n is less than 5. Check. We go back to step 3. Okay, so back to step 3. Step 3 says let c equal a plus b. So A plus B is 1 plus 2 equals 3. So then it says write down C. So C equals 3. Number 5, let n equals n plus 1, A equal B, B equals C. Then if n is less than 5, is n less than 5? Yep, go to step 3. So we go back to step 3. Let C equal A plus B. 2 plus 3 is 5. Step 4, write down C. C equals 5. Step 5, let n equal n plus 1, 4. Let A equal B, 3. Let B equal C, 5. Is n less than 5? Yes, go back to step 3. Let C equal A plus B. 3 plus 5 is 8. Write down C. C equals 8. Number 5, let n equals n plus 1, 5. A equal B, 5. B equals C, 8. If n is less than 5, go to step 3. N is not less than 5. If n equals 5, stop. And then sometimes it might say print C. So then you'd write print 8. Okay, here is a typical exam question. This exam question is worth 5 marks. Off you go. Okay, so input A and B. Now I'm going to input it all, and it says 2 and 3. I'm just going to use the small lines that I have. Let C equal 0 and D equal 0. Let C equal C plus A. 0 plus 2 is 2. Let D equal D plus B. 0 plus 3 is 3. If C equals D, then go to line 110. Nope. If C is greater than D, then go to line 90. C is not greater than D, though. Okay, 70. Let C equal C plus A. 2 plus 2 is 4. Go to line 50. If C equals D, which it doesn't. Okay, is C greater than D? Yes. Go to line 90. Let D equal D plus B, 6. Go to line 50. Is C equal to D? No. If C is bigger than D, then go to line 90. No. Let C equal C plus A. 4 plus 2, which is 6. Go to line 50. If C equals D, then go to line 110. Yes, they equal each other. 110, print C. Okay, so C is now 6. Print 6. End. Okay, so stop right there. Okay, so state the purpose of this algorithm. Now, what connection do we have with 2, 3, and 6? I know a lot of you have said that 2 times 3 equals 6, which is true. If we were to try this on another number, though, we would see that wouldn't necessarily be the multiple, okay? What we're actually finding is the lowest common multiple. So even though we're multiplying them, we're trying to find the lowest common multiple. It then says, write down the final value of C in the case where A equals 200 and B equals 300. So if we're still trying to find the lowest common multiple of 200 and 300, it is in fact 600. Because all we've done is A is 2 times 10 squared and B is 3 times 10 squared. Once we've found the lowest common multiple of A and B, we then need to just multiply, which we know 6 times that by 10 squared, which is 600. We wouldn't have to do the whole process again. Okay, our next thing that we're going to move on to is flowcharts. And there are 3 shapes of boxes which are used in the exam, okay? We have a rectangle with curved edges. This is always a start or an end box. We have a normal rectangle. This is an instruction. And then we have our diamond, okay? This is always a decision. Okay, a decision that needs to be made. And it will be linked together with arrows. So here's a nice example for you, okay? Start. Let n equal 0. Great. Let n equal n plus 1. 0 plus 1 is 1. Let e equal 2n. 2 times 1 is 2. Print e. Done. Is n greater than 9? No. Okay, and then as you can see, we follow the path back up. Let n equal n plus 1. 2. E equals 2n. 4. Print e. Is n greater than 9? No. Then we go back. N equals n plus 1. 3. 3 times 2, 6. N is not greater than 9 yet. 4, 8, no. 5, 10, no. 6, 12, no. 7, 14, no. 8, 16, no. 9, 18. Okay, is n greater than 9? Still no. Okay. 10, 20. Is n greater than 9 now? Yes. Okay, stop. We've done it. We filled the table out. This is it. Really nice and simple. Okay, here's another example for you to try. Okay, so we're going to try it on A, and then B, and then C. So this flowchart can be used to find roots of an equation in the form ax squared plus bx plus c. So you can have a look at this and give it a go. Okay, so the first one, our A is 6, B is negative 5, and C is negative 11. It then says, let D equal B squared minus 4AC, 289. Is D less than 0? Nope. Is D equal to 0? Nope. Okay, so then we substitute in our answers into here, and then we're going to print roots are. Okay, now it says print roots are. So you have to actually write, oh, then you put rots on. Roots are, okay, and you have to write x1 equals, work out the calculation, 11 over 6. x2 equals negative 1. If you do not print roots are, you will not get the full marks. For the second one, our equation is 1 minus 6, 9. And when I substitute d in, I get d equals 0. Is d less than 0? No. Does d equal 0? Yes. So you can see here, when d equals 0, we've got to print equal roots and x equals and substitute in. So equal roots. Okay? And then we're going to write x equals, substitute 6 over 2, which is 3. Part C, I'm going to put in our A, B, C, 4, 3, and 8. We're going to substitute them into B squared minus 4AC. We're going to get negative 119. Is D less than 0? Yes. Now, I don't need to write no here, because if D is less than 0, this is before this one. So if D is less than 0, yes, print no real roots, and that's it. No real roots. If you had have put here, D, if you'd have put no here, you would have gone wrong and lost a mark, because you have to follow the flow chart. Okay, so here's a test your understanding question. Give it a go. Okay, so I am going to condense this down a little bit because I don't have that much room. But input A and B, A is 16, B is 12. Okay, right. 1, 2, is B equal to 0? No. 3, is A greater than B? Yes. Okay, so this is, I pretty much did steps 1 to 3 all in one then, okay? It's fine. So B is greater than 3. So from here, yes, so then I go A now equals A minus B. Step 4. A now equals A minus B, which is 4. Okay? Go to 2. Up I go, back to 2. Okay. Then B equals 0. No, does B equal 0? Wait, what? Put 4 in. Go back to 2. Does B equal 0? No. Is A greater than B? Okay, is 4 greater than 12? No. Okay. B is B minus A. 12 minus 4 is 8. Okay, where am I now? Step 4, 5? I have no idea. Okay, then go to 2. Okay, back round I go to 2 again. Back to 2. Does B equal 0? No. Is A greater than B? No. Okay. B is B minus A. 8 minus 4, which is 4. Go all the way back to 2. Go back to 2. Does B equal 0? No. Is A greater than B? No, because it's not greater than or equal to, is it? Okay. Oh, we're doing steps 2 to 5 again. B is B minus A. 4 minus 4, 0. Okay. Go back to 2. Great. Back to 2. Does B equal 0? Yes, it does. Ah, right there, somewhere new now. All the way down to here. Print A. Okay, what was our A? 4. So we are going to write print 4. Okay, it now says, what is this doing? Well, if we think about it, we had 16 and 12. The answer was 4. I know exactly what it was doing. It was finding the highest common factor of A and B. Okay, so here's a typical exam style question with an A, B and C. Off you go. Voila. Here is the answer on the screen. And you can see where all the marks come from. And then here it gives the prime factorisation of a number and C equals 1. Okay, so we should have got that. Yeah, if you can do this one as well, you can see this one is an 11-mark question. Okay, with A, B and C. On the next slide is a table if you need it. Okay, so now you should, here is the solution. Please double check that you've got this correct. And you should be happy with this. Okay, we've now finished. Here is the table if you need it. Flowcharts, so, and trace tables. So if you need more help, please use the Pearsons book and do a few of the questions. Okay, moving on, bubble sort, okay. So we're going to use this to put a list of values in either ascending or descending order, okay. This helps us with binary search, finding an item. We can find values within a range. You can find the medians, the quartiles, and it's, you know, it's to sort people by surname. You know, if you go onto Excel and you like click sort by last name, you know, in the background, what is it actually doing? Sometimes they do use bubble sort. So this is what's going to happen. Here we go. So we're going to look at each pair of values in turn and swap them if they're in the correct order, okay? So this is known as one pass of the algorithm. So because it wants us to put them into the correct order, what we're going to do is we look at 19 and 31. If they need swapping, we'd swap them. Now, 19 is less than 31, so essentially it then looked like this, 31. And then it looked like 55, 42, 2, 112 and 67. What we would then do is we've looked at the first two. We then, okay, was once we've swapped them, we would then look at the next two. Okay, if we look at these two, there's no swap that needs to be made. So I look at these, there is no swap. I then move on to the next two, 55 and 42. I would need to swap this. Okay, so essentially, let me just... This was built for PowerPoint, but here we go. Make a bit more room. So now I'd look at 55 and 42. 19, 31. I would swap these. 42, 55, 2, 112 and 67. I would now look at 55 and 2. Again, I would swap these because 2 is less than 55, 112, 67. I would then look at 55 and 112. I don't need to swap them because they're in the right order. And then lastly, I look at 112 and 67, which I would need to swap. So 19, 31, 42, 2, 55, 67, 112. Okay, so this is actually known as one pass, okay, of the algorithm. We're not done, but we definitely know that one value is in its correct place. Okay, one value will 100% be in its correct place. So 112 is the one that is in its last place. Okay, so we know, not in its last, it is in the last place, but it is in the correct position because even no matter where in the list 112 would have started, we would have kept passing. So 112 is done and this is in the correct position. Okay, what we can then do is a second pass. But we don't need to worry about the last value, okay? Because we already know that it's in the correct position. So if I was starting to do the second pass, 19 and 31. Let me just get this. Here we go. So we have 19 and 31, no change, okay? Because that is in the correct order. 31 and 42, no change. 42 and 45, no change. 55, sorry. 55 and 2, we would. This would now be 19, 31, 42, 2, 55, 67, 112. But again, we don't need to worry about that. That is boxed off. And then, lastly, 55 and 67, no change, okay? So after the second pass, we know now that 67 is also in the right. This is the second pass. Is also in the right place, okay? We keep going and we stop if there's no swaps or passes. So, my third pass, essentially. Okay, now we've got this, 19 and 31, no swap. 42 and 2, we are going to swap. 42 and 45, no swap. And then we know that 67 and 112 are safe. So now we know that 55 is also in the right place. So this is what's called our third pass. Okay, now the next pass. 19 and 31, no swap. 31 and 2, yes, we are going to swap. So we've got 19, 2, 31. And then 31 and 42, we're not going to swap. So now we know that 42 is also in the right place. This is our fourth pass. Okay. Keep going. 19 and 2, we are going to swap. 19 and 31, we're not going to swap. Now we know that 31 is safe and is in the right order, and we know the rest are. This is our fifth pass. I think I've spelled fifth wrong. Okay. Next up, 2 and 19. We have to check. No swaps, okay? But we did check just in case. Okay, so this is our sixth pass. Stop. Okay, we stopped because there was no swaps or passes. Okay? Oh, I mean on this pass. So we stopped because there was no swaps. So on each pass, look at each pair of terms left to right, swapping if in the wrong order. Keep doing further passes, ignoring one extra value at the end of each time, and you are done if there were no swaps or passes. Okay, I want you to think about the pros and cons of this. I'm going to give you 2 minutes and then we're going to talk through it. Okay, so it is easy. It's easy to do. It's a simple set of instructions, isn't it? Okay. And then someone's put, it could take long. Absolutely. Could take a long time. We're going to look into why in a second. So it is easy also to check for errors on the way. And you can also look at the steps. Also, if a list is size n, for example, if a list is size n, each time you only need to do n minus 1 comparisons. Okay, so then the cons. It's not very inefficient, okay? It's just extremely inefficient. And that is because each time we're having to do a certain amount of comparisons, aren't we? Okay? The comparisons on the first pass, if we remember what we did before, you saw how long that list was on the first pass. Now, if we were to write this out, on the first pass, you know, you're going to do n minus 1 plus n minus 2 plus ... plus 3 plus 2 plus 1. This is actually a quadratic sequence. Okay? So we would say that bubble sort has quadratic order. Okay, so this is an exam style question, and we can see that this is 5 marks. But how are you going to get these 5 marks? Okay, so it says the list of numbers above is to be sorted into descending order. Please make sure you know if you're doing ascending or descending order. Okay, so descending, we want biggest to smallest. Part AI, perform the first pass of bubble sort giving the state of the list after each exchange. This is really similar to what I did just a second ago. Okay, so step 1, always write the list out. Okay? So 25, 22, 30, 18, 29, 21, 27, 21. Now, as I said to you, we will need colours and highlighters, and it's just going to make it easier because to get these 5 marks in the mark scheme, you have to really show what's going on. Okay? So, step 1, 25 and 22. We didn't swap them. Okay? Write the list again. Because 25 is bigger than 22. Remember, we're doing descending this time. Okay, the next one, 22 and 30. We are going to swap them. 25, 30, 22, 18, 29, 27, 21. Okay, we're now looking at 22 and 18. There is going to be no swap. Okay, 25, 30, 22, 18, 29. Oh, yep, 21, 27, 21. The next one we're looking at is 18 and 29. I've just realised I'm writing too many steps, but I'll show you the ones that we need to do, which we are going to swap. So 25, 30, 22, 29, 18, 21, 27, 21. We're now looking at 18 and 21. 25, 30, 22, 29, 21, 18. I wish there was like a fast forward button, but there isn't. Sorry guys, I'm going as fast as I can. 18 and 27. We are going to swap. 25, 30, 22, 29, 21, 27, 18, 21. Okay. 18 and 21. We're nearly there, everyone. So then we've got 25, 30, 22, 29, 21, 27, 21, 18. Okay, stop. This is literally our first pass, okay? Going to use a different colour. We know that 18 is in the exact correct place now. Now, part A is perform the first pass of bubble sort, giving the state of the list after each exchange, okay? So what we have done is I have put too many on there because, for example, the one line we probably didn't need to put on there is the 18, the 22 and 18, and then we've got 18, and if we have a look at the mark scheme, we probably didn't have to do this first one, and we didn't have to do, we didn't have to write this first one. The rest, 22 and 18, we didn't have to write this one either, okay? Because we didn't have to move it. But, you know, when in doubt, write it out. I just suggest you only need to do the first pass, okay? Just write it all down. It's 5 marks because it's going to take you 5 minutes. And then part II, because this is just A part I, okay? And this is our first pass. And always write it down on the side, first pass. Okay, it says perform further passes given the state of the list after each pass until the algorithm terminates. So now for II, you don't have to do this, write the whole thing. What you can do is this. 25 and 30, you know that's going to swap. So you know that's 30. 25, now you think 25 and 22, not going to swap, okay? You then think to yourself 22 and 29, that does swap, so 29. 22 is now here, 22 and 21 does not swap. 21 and 27 does swap. 21, 21, 18, okay? So, 21 and 18 are now safe. And this is what we call the second pass. Now you can see for this one, I didn't write out each individual one because I just did it in my head, and you don't have to write out each individual one unless it specifically says. Okay, the third pass, 30 and 25, don't go. 25 and 29, that will move. So when I have 25 and 22, that doesn't move. 22 and 27, that does move. 22 and 21, that doesn't move. Okay. So I now know that this 21, oh, different colour, sorry guys. This 21 is safe, this 21 is safe, and this 18 we already know is safe. Okay? So this is our third pass. Okay, next, 30 and 29, nothing. 29 and 25, nothing. 25 and 27, yes. 25 and 22, nope. 21, 21, 18. Okay, get your highlighters out. We know these ones are safe. And now we know that 22 is safe. This is the fourth pass. Okay, now we've got our fifth pass. 30, 29, no change. 29, 27, no change. 27, 25, no change. I don't need to compare it with 22 because I know that's safe. Okay, stop. Sort complete. You need to make sure you write that final sentence. There we go. The sort is complete because we had no swaps in the fifth pass. Okay, you don't have to write that, but just no swaps in the fifth pass. Perfect. Okay, guys, test your understanding. You want to put this in alphabetical order. Okay, I'm going to give you 3 minutes. Off you go. Okay, so after the first pass, we think A and L. We know that A is the first letter anyway. Okay, L, G. Well, G comes before L in the alphabet, so I would do that. I then have L and O. L comes before O. O and R. O comes before R. R and I. I comes before R. R and T. R comes before T. T and H. H comes before T. T and M. M comes after T. Perfect. Okay, so we know that T is in the right place. Now, this is after our first pass, okay? Then again, A and G is fine. G and L. G and L. Yeah, G comes before L. L comes before O. I comes before O. O comes before R. H comes before R. R. M comes before R. Whew, okay. Sometimes it gets a bit much saying all these letters, but this is why I had to write the alphabet on the side. Okay. A, G, L, I comes before L. L, O, L comes before O. H, O, H comes before O. M, O, M comes before O. R, T. Okay, next one. A, G, fine. G, I. G comes before I. Yes, it does, doesn't it? Right, L, H. H comes before L. L, M. Okay. Right. Okay, A, G. Fine. G, I. Fine. H, I. H comes before I. I, L. Yep. M, O, R, T. Now, even though some of you may be thinking, we've done it. No, we have not. We always need to do that pass to double check. A, G. Fine. G, H. Fine. H, I. Fine. Okay. Now we are finished. And the most important thing to get that last mark, sort complete. Woohoo! Now, sometimes in past exam questions, they don't even want you to do bubble sort. You know what they want you to do? They want you to describe or explain, okay? So we really need to understand what's going on. So, a list of 9 numbers needs to be sorted into descending order. Describe how to carry out the first pass of bubble sort on the numbers in the list. So you've got to describe how to do it, and you've got 2 marks, okay? It then says Maylene used a sorting algorithm to sort a list of 9 numbers into descending order. Maylene's list after the first pass through the algorithm is given below. Explain how you know that Maylene did not use the bubble sort algorithm. Dun, dun, dun. Okay, so 4 marks, 4 minutes. Do you have this? Off you go. So what I'm actually going to do is take a picture of the mark scheme for you guys. Okay, so here is the mark scheme. So let's have a look at it. So remember, we can either start left to right or right to left, okay? So if starting from the left end of the list, in the first pass, we compare the first value with the second value and we swap these values if the second is larger than the first. We then compare the value, which is now the second and the third value, and swap if the third is larger than the second. We continue in this way until we reach the end of the list, okay? So if you've got something similar to that, I think the best way in this case is I will read through and then we can double check. Then there's two possible reasons here and you get 1 mark for each one. So we know from earlier that when we do bubble sort, one of them after the first pass would be in its correct order. Malin said that this was after 1 pass. Now, if she'd have gone from left to right, then 15 would have definitely been on the end because that would have been the smallest. If she'd have started at this end and worked this way, we know the smallest one would be here because we want the biggest one here each time. But if she'd have started from right to left, then the biggest one would actually be here, which is 35. So she's incorrect because she neither has the smallest one on the right-hand side or the biggest number on the left-hand side, okay? Okay, so here's a grumpy examiner's report. Is he talking about you? I hope not. Right then, so you can see here that in the examiner reports, they can see that, you know, it's just a lack of completeness and precision on the part of many students, okay? This is why when I showed you earlier how to do it, we do every step. Even though the mark scheme said we didn't need 2 lines, remember, when in doubt, write it all out, okay? That is the motto for D1, okay? Just to be sure. Okay then, so here is another test your understanding, which you're going to do very quickly. Remember to write first pass, second pass, etc. Sort, complete, all of that. 4 minutes. So we should always start with the list, write it out again. Okay, now think about our first pass. 52 and 48. Would we change them? No, because 52 is bigger. 48 and 50, yes we would. 48 and 45, we would stay the same. 45 and 64, that would change. 45 and 47 would also change. And 45 and 53 would also change. Okay, so this is our first pass. Okay, and you can write on the side, first pass. Now you can see here, 45 is our magic number now. We don't have to worry about that. Next pass, 52 and 50 can stay the same. 50 and 48 can stay the same. 48 and 64 can definitely change. 48 and 47 can stay the same. 47 and 53 can change. And then we know we have our 47 and 45. 52 and 50 can stay the same. 50 and 64, they can change. Oh, getting ahead of myself. 50 and 48 can stay the same. 48 and 53, that can change. 48, 47, 45. So this is the second pass. Third pass. Okay, and again, using our nice colours, we know that 48, 47, 45 are all done. Okay, 52 and 64 can change. 52 and 50 can stay the same. 50 and 53, that can change. 48, 47, 45. That was our fourth pass. 50, 48, 47, 45. Okay. 64 and 52 can stay the same. 52 and 53, that can change. 50, 48, 47, 45. 52, 50, 48, 47, 45. Okay, that was our fifth pass. Okay, our sixth pass. 64 and 53 can stay the same. And then 48, 47, 45. We know that's it. Okay, stop. And our magic words. Sort. Complete. Woohoo! Give yourself 4 marks. Okay, so here we have a quick bubble sort quiz. There's 4 questions. I need 4 answers. You've got 4 minutes. Off you go. Which number is definitely in its correct position at the end of the first pass if sorting a list into ascending order? Okay, now remember, there's 2 answers. If sorting left to right, which is what we've been doing, okay, then if it was in ascending order, the largest number would be at the end, okay? But if we were sorting, if we decided to read like the Arabics read, from right to left, because you can do it that way if you want, then what would be the smallest number would be in the correct position. Okay, so please remember both of them. Question 2. How does the number of comparisons required change as the pass number increases? So each pass, okay, needs or requires 1 less comparison than the last one. Comparison than the last pass. And the reason for that is because each time we do it, you remember each time we do it, remember after the first pass, that number's safe. So then on the second one, these 2 numbers are safe. Then the 3 numbers are safe, okay? Number 3, how does the algorithm know when the list is sorted? So it's sorted when there are no more swaps in a pass, okay? So a pass is like each stage. So when you do no more swaps within one of the passes, that's when we know. Okay, what is the maximum number of comparisons required for a list of 10 numbers, and does it always need to be this many? So in the first pass, okay, there would need to be 9 comparisons, okay? And in the second pass, we'd have 8 comparisons, okay? This is comparisons for the total list. So 9 plus 8 plus 6, 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is 45, okay? So 45 would be the maximum number required for the list, considering that we would have to do, if we had 10 numbers, and we'd have to do 10 passes, okay? Nine passes. Right, and then the 10th pass would be there would be no swaps, okay? But it doesn't always need to be this many, because if the list was already in order, we'd only need 9 comparisons, okay? Or if the list was half in order, we wouldn't need as many. So if list was in order, only 9 comparisons needed. Okay, and if it was half in order, we'd need less than 45. But the key thing is that 45 would be the maximum. If you need further practice on this, please use the textbook and go through some of the questions. Okay, we have a different type of sort now. We had bubble sort, now we've got quick sort. Okay. So quick sort's a bit different because it's more about dividing and conquering, okay? We need a pivot, and then what it does is it chooses that pivot, and then it looks at the left-hand side of the pivot and the right-hand side and swaps if needed, okay? So, quick sort, here are the rules for it. You select a pivot and then split the items into 2 sub-lists. Those lists less than the pivot and those greater than the pivot. So choose the item at the midpoint, write down all the items, write down the pivot, write down the remaining items, apply steps 1 to 4 to each sublist. When all items have been chosen as pivots, stop. Okay, so I just really briefly read through those instructions because even though those are the instructions, I'm going to show you what to do, okay? So here we go. Right, are we ready for the example? So, first of all, we're going to choose the pivot, okay? And it's going to be the midpoint. So we can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9. The pivot is the midpoint. If it was an even list, okay, you could choose the right of the middle or the left of the middle. It doesn't matter, but you have to be consistent throughout, okay? As long as, if it's an even list and you choose the left or the right, as long as you're consistent throughout, it doesn't matter. Okay, so step 1, choose the middle. Okay, so this is an odd list. It's nice and easy for us. We have chosen 23, okay? Now, what I do is I look at all the items that are less than the pivot, keeping them in order. So, for example, is 21 less than the pivot? Yes, it stays here, okay? Is 24 less than the pivot? No, so it needs to move here after it. Okay, so let's just put 24 here. Right. Oh, sorry, I'm going to keep 23 here. 24 would now move here. Is 42 less than the pivot? No. So 42 goes here. Is 29 less than the pivot? No. So 29 goes here. Okay, is 13 less than the pivot? Yes, so 13 would go here. Is 8 less than the pivot? Yes, so 8 would go here. Okay, I highly suggest you highlight your pivot. 39 is not less than the pivot, and neither is 38. So we can see we haven't kept the order. We've kept the order of the place, but you can see it's slightly swapped, okay? Right, now, 23, we're going to rewrite down here. Okay, we're going to write 23 again, but this time, 23 is already been used as a pivot. Okay, so now we need to find a new pivot. So we do a pivot on the left-hand side of our old pivot. So here we have, again, we have an odd set of numbers. So our pivot is now 13. So I'm going to write 13 and I'm going to circle it because this is our new pivot on this side. Okay, so now I have this pivot. I look to the left-hand side. Okay, I only have these 3 numbers to work with and I just move them as needed. 8 is now going to move here because it's less than 13, and 21 is now going to move here. Okay, so 13 has now been our pivot. Right, and again, this is our new pivot. Now, I look on the other side of the list. What's in the middle? 29. So 29 is our new pivot. Okay. Anything less than 29 goes on the left-hand side. 24. Anything greater than goes on the right-hand side, still staying in order. 42, 39, 38. Okay. So now, these are already been pivots. Okay. So, what I now look at is I can only stop when all items have been chosen as pivots. So now I would choose 8 as a pivot. Well, I know that's just 8, okay? Because it's on its own. So now that's done. I'm now going to choose 21 as a pivot. Again, the 21 is in between 2 green numbers now. These green numbers are in their right place. So 21 is now in its correct place. I'm going to choose 24. Your pivots are always in between your previous pivots. 24 is in its correct place. Now I have 39. Okay, 39 is a new pivot. Okay, oops. Oh my. Okay, so now 39. I need to have a look at which way this should go. Now I do in fact need to swap some numbers around. Okay, because 38 is less than, oops, not in pink though. 38 is less than 39 and 42 is greater than. Okay, now remember all the numbers in green, they're in their fixed positions. You know from using the pivots that these are correct. Okay, now what do we have? We have two other pivots, 38 and 42. Now, because they're in between a pivot and a number which was a previous pivot, you know it's in the right order. So there we go. Every number has been chosen as a pivot, and now the list is in order. The most important thing to write at the end, sort complete. Okay? Okay, so here is another example. So the list of numbers shown above is to be sorted into ascending order. Apply quicksort to obtain the sorted list. You must make your pivots clear. Okay, this is a 5-mark question from an exam question. Okay, so step 1, we're going to write the list out. 18, 20, 11, 7, 17, 15, 14, 21, 23, 16, and 9. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So 15 is now our starting pivot. Okay, we need to make it clear that this is our pivot. So when we look at the list, we have a look. We write 15 down. We now know that 15 is going to be in the correct order, no matter what happens. We've already used 15 as our pivot, okay? Now, everything that's smaller goes to the left, everything bigger goes to the right. So have a look. 18 goes to this side. The next number, 20, this side. The next number is 11. That goes on this side. Next number, 7, this side. 17 is greater than 15, so it goes on this side. 14 is less than, so this side. 21, greater than 15, goes on this side. 23, greater than, goes on this side. 16 is greater than, goes on this side. And 9 is less than, it goes on this side. Okay, so that's done. We now, because our 15 is secure, we look for a pivot on the left-hand side and a pivot on the right-hand side of the 15, okay? So this 15 is now in its place, and as you can see, we've got 1, 2, 3, 4, so 4 numbers. Now this definitely tells me that this will be the 4th number. As you can see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So if I was to write the completed list down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, 11, sorry. If I was to write that, wait there, guys, it's not in the center. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's better. So I know the 4th number is definitely... the 5th number is definitely going to be 15 here, because 4 on this side, and then I've got the rest on this side, which is 6. So 15 is definitely the 5th one. 1, 2, 3, 4, 5. In our sorted list, 15 is here. So if you wanted to, you can just write an arrow down, or you could keep writing it. We're going to keep writing it, but just so you know. So now I need to choose my pivot on each side. As you can see here, normally I choose the middle number, okay? But we don't have a middle number. You can choose left or right. Personally, I like to go right. So I'm going to go with 14. So 14 is our new pivot on this side. And on the other side, again, I need to choose the middle of this number, 18, 20, 17, 21, 23, 16. The middle is here. I go slightly to the right, so 21. Now, if you go to the right, you have to always go to the right on this particular question. So I'm now going to write my pivots again, okay? And now I can start sorting these out. So just on this, anything less than 14 goes on this side. So 11 is, 7 is, and 9 is. Brilliant. Then I nothing is in between, so that's fine now. 18, 20, 20, sorry. 18, 20, 17, 23, and 16. So I have a look. 18 is less than, stays here. 20 is less than, stays here. 17 is less than, stays here. 16 is less than, stays here. 23 is larger than. Okay, so if I wanted to, I know that 21 would be the second to last one. Okay, and I know that 14 would be the fourth one along. Now, I'm going to rewrite these again. I'm just going to move 14 a bit closer to 15 so we've got a bit more room. And I'm going to move 21 here. Okay, our new pivots. 7 is now my new pivot because that's in the middle of everything to the left of 14. In between 15 and 21, my new pivot would be here, but I'm going to go to the right. So 17 is my new pivot. And then on the right of 21 is 23. Now, I'm going to write 7 here, 17, and 23. So let's have a look. So 9 and 11 are greater than 7. And I've written them in the wrong order, sorry. First, we look at 11, moves to this side, then 9 moves to this side. Okay, 17, 18, and 20 are greater than, 16 is smaller than. Okay, done. Now I now know that 7 is the smallest one in the list. Okay, I know that 17 goes here, and I know that 23 goes on the end. I now look for my new pivots. Remember, I go to the right, so in the middle of 11 and 9, there's nothing. So now 9 is my pivot. In the middle of 15 and 17, 16 is the pivot, and then 18 and 19, there is no middle, so I go slight to the left, to the right, which is 20. I now have, I've got so many colours going on. Okay, so 7, 9, 14, 15, 16, 17, 20, 21, 23. And 11 moves to the right-hand side, 16 stays, and 18 stays as well. Now I need to do 11 and 18 as my pivots. Now, because they're just on their own, they are what they are. I have to highlight them as pivots though. Okay, now because I don't need them anymore, because they're on their own, there's no numbers to pivot with, that's okay. We now have our correct order. 16, 18, and 20. Okay. My pivots are highly labelled when we chose them as pivots because that's what's highlighted. And then after they've been chosen as a pivot, they are stuck where they are. They cannot be, we can't swap them around, okay? So that's why they're then in green. If you wanted to, you could write pivots, and then here you know your pivot is 15. Here your pivot is 14 and 21. Here your pivot is 7, 17 and 23. On the next line your pivot is 9, 16, 20. And then lastly your pivot is 11 and 18. Okay, if you wanted to, just to make sure that you've got everything down, you can do that. Okay, here we go. Test your understanding. This is 4 marks. Off you go. If you're watching this on YouTube, I suggest you press pause because I'm just about to put the answers in. Okay, so here are the answers. Now, I don't know if you can see from the screenshot, but these are actually highlighted in the mark scheme, as well as there is a list. Even though on this row here, they haven't written V as a pivot, they have used it, but because T was already pivoted on the one before, your V, even though it's a pivot, there is no changes to actually do, but you still have to highlight it, okay? Okay, and here is another test your understanding, another typical exam question. This is worth 5 marks, okay? So I would like you to give this a go. And in the mark scheme, what we're going to see is a slightly different way of how they've labelled theirs using bold and underlining. So in the one before, we saw a nice table with a list. So it really does depend what you do. Okay, off you go. Pause now, or else I'll put the answers up. Okay, so on this one, we can see that their pivots are highlighted in bold in the mark scheme, and you need to make sure that you are visibly showing your pivots, okay? Brilliant. And then once that pivot is sent to place where we were writing them in green, what they've done is underline them to say this is now their permanent place, okay? So you can see that. Nice and easy 5 marks. They've also written a table of the pivots used as well. Okay, so here's a challenge for you. Once you've done this, do this as a bit of fun on the side, and then write the answers, send them to me, so you can get maybe a little prize, okay? If you need any more help with this, please use the decision book. But that is it for quick sort. Okay, bin packing. So, the bin packing problem. It's just, imagine you're trying to fill a box and you've got loads of different other boxes, okay? And you want to find the best way to use the least amount of boxes. I always see it as a logical puzzle, okay? You've got 3D bin packing or 1D bin packing. Okay, and, you know, like 2D bin packing, okay? So, first of all, we're just going to have a look at lower bounds. So, 9 boxes of fixed cross-section have heights in meters as follows. Okay, so we've got these boxes and these are the heights. They are to be placed into bins with the same fixed cross-section and height 2 meters. Determine the lower bound for the number of bins needed. Okay, so first of all, we've got to add all of these up to find the lower bound, because essentially, if the width and the depth is the same, we don't need to worry, it's just about the height. If we add them all up, so 0.3 plus 0.7 plus 0.8 plus 0.8 plus 1 plus 1.1 plus 1.1 plus 1.2 plus 1.5, okay? The heights of all of them are 8.5. If I think that each bin can only have 2 meters high, of course, I'm going to divide it by 2. Oh no, oops. Okay, 8.5 divided by 2. Okay, immediately I know this is 4.25. Don't need a calculator for that. If I need 4.25 bins, that means actually I need a minimum of 5 bins. Okay? Now, even though you know this is a lower bound, what we're going to do now is we're going to have 3 different types of bin packing algorithms, okay? And then we're going to be able to decide which one is the best one. Our first algorithm is called first fit algorithm. Whatever order they give us in, okay, so imagine we're in a, we're on a machine belt. They give us, the orders are coming through, we just put it in a box. We keep going, it doesn't fit, okay, next one, put it in. That's what we're going to do, okay? So the advantage of this is it's quick, okay? It's quick to do. We don't need to have any prior, do anything to the list or the boxes. We don't need to sort them or anything. It's just quick and easy. The disadvantage is probably not going to be the best solution, okay? I mean, it could be sometimes, but not always is it going to guarantee the best solution. So we're going to have a look at this first fit algorithm. Okay, so here we go, guys. We are in a factory, okay? And you're being passed these things to put into these bins, okay? So your first box that comes is that each bin can only take a maximum of 20, okay? And whatever goes, goes. So here we go. We are in the bin, okay? Be in the moment. Imagine you're there, right? Okay, the first parcel comes. Boom, it's 8. Fantastic. I'm going to put that in bin 1. Okay, now remember the maximum for each bin is 20. Okay, you'll see it poking out the side. Okay, the next parcel comes, 7. Great, that'll fit. Perfect. Remember we're on 15 now, okay? Next parcel comes, God, this is a long one. 14. That's not going to fit in the first bin, but it doesn't matter. I've got the next bin there waiting, so I'm going to put that straight in the next one. The next one comes, it's 9. Yeah, that's definitely not fitting in the first bin, because I've already got 15 here, haven't I? I've only got 5 left. In this one, I've got 6 left. Right, it's going to have to go into bin 3. Okay, the next one, 6. Ah, yes. So, it doesn't fit in the first bin, because I've only got 5 left. In the second bin, it fits in. Okay, this bin is now full, so I'm just going to chop that bit off, okay? It's a full bin, 20, done. Okay, next one comes flying at you, 9. Okay, it doesn't fit in the first one. Second one's full, it does fit in the third one. Now that's at 18. The next one is 5. Perfect, I know that fits in the first one. Okay, this one is now full as well. 15. Whew, God, that doesn't fit. New bin. Okay, next one's flying at you, 6. Okay, it's going to have to go into a new bin because it doesn't fit in bin 3 because that's at 18. Bin 4 is at 15. So I is 6. Next one is 7. Oh, God. Okay, that does fit in bin 5. J is 7. Okay, 6 plus 7 is 13. The next one comes flying at you, it's 8. Oh, no. Doesn't fit in any. Going to have to do another bin. Oops. Oh, there we go. Okay, so this is K8. Okay, so we've had to use 6 bins. But if we just stop for a minute and think about the waste that's going on. This one had 2 left over, didn't it? This one, oops. This one had 2 left over. This one had 5. This one had 7. And this one had 12. Okay. If I add them up, 26 wasted. Okay, that's a lot of waste, really. It's probably not the best method. But nobody panic. I'm going to introduce you to another algorithm. Okay, so what we're going to do is try to get first fit decreasing algorithm. So this time we're going to reorder the sides in descending order and apply the first fit algorithm to the reordered list. So the advantages of this is, probably going to get a better solution, okay? A better solution. It might not be the optimal one, okay? So that could be a disadvantage. So may still not be optimal. Okay, but we are going to have a better solution, and also it's also easy to do. So we're going to try it again on the same set of numbers. Here we go. Step 1, arrange in descending order. H15. Then we're going to have C14. Next up is, I think it's 9. E9. F9. Oops, didn't see that one. D9. Okay, then it's 8. A8, K8. A8, K8. Now, just to let you know, probably should put the D first. Okay. So D9, then it was E9, wasn't it? Wait, was there another 9? I think I've written something down wrong. Oh, it was E6. Yep. Okay. F9. A8. Yeah, that was 6. Sorry, guys. A8, K8. J7. Then we've got, oh no, B7 first, sorry. Then J7. Then we've got E6. I6. And then we've got G5. Okay, make sure you write them in order. Okay, now we're going to fill the bins in. So this one, we're going to start H15. Okay, then we've got C14. Then we've got D9. Okay, now F9 will be able to fit in here. A8. K8. 7 doesn't fit anywhere. B7. J7. E6. Ah, that goes up here, look. So we can fit that in. I6 can go 7 plus 7, I6, and then G5. So there we go. As you can see, I've now got 5 bins. And if we look at our waste, no waste here because that's 20. No waste here because that's 20. I'm wasting 2 here, 4 here, and no waste here. Is that right? Yeah. So actually, we've only got 6 units wasted. That's a lot better. That's minimal waste compared to the other one. Imagine if each bin cost 100 dirham to ship. We'd save ourselves 100 dirham. It's fantastic news if you ask me. So, the next one is called full bin packing, okay? So this time, it's just using your observations to find combinations of items that will fill a bin, okay? Pack these items first, and then any remaining, we use the first fit algorithm. So, advantages of this. Again, probably going to get a good solution. Because if we looked at, the 20 and 5 we put together, 15 and 5 put together, that makes 20. Okay? Disadvantage, it could be difficult if we had like loads of numbers, or if we had like decimals, and we had like 1.25, then we had 0.36. It just, it's just not very great. So here we go. What we're going to do is, I know looking at this that I would pair up. So my pairs are going to be, wait, is this a different list? Yeah, this is a different list. Okay. Right, the above items are to be packed in bins of 25. Okay, I'm going to look for any numbers that are going to make 25. Okay. So A is 8. Okay, and F is 17. That makes 25. I know that's a full bin. Okay, what else makes 25? Oops, wrong colour. Sorry, guys. Here we go. J and D. Okay, J and D, they're going to make 25. Okay, any other numbers that make 25? Or close to 25? Yes.
E and
Yeah.
I.
E and I. Right, E 13 and I 12. Okay, so I can put these in. So we can have A8, F17, that's full. We can have J14, D11, that's full. We're going to have E13, I12, that's full. Okay, now the rest, we have to use what's it called? First fit.
Miss?
Okay, we've got another bin as well. K9. Oops. Wow, what was that? K9, H6, C10. That adds to give me 25 as well. K9, H6, C10. K9, H6, C10. Perfect. And then obviously in the last one, we've just got B7, and G4. So there we go. We've managed to fill 4 bins on our own, and then the last bin we just put in first fit. Perfect. Now I've realised I've done something really terrible. It's not that terrible, but really step 1, read the question. Okay, we should have determined the lower bound. So this is the minimum amount of bins needed. We add them all up, so our 8 plus 7 plus 10, blah, blah, blah. And then we divide it by 25, and we're going to get 4.44. So therefore, 5 bins minimum is needed. Okay? Then, part C, is your solution optimal? Okay? Now, it's optimal if our solution is the same as the lower bound. Okay? Lower bound equals 5. Our solution equals 5. Therefore, optimal solution. Okay, so it's optimal if it is the same as lower bound. Oh, I've put bond. Perfect. There we have it. Bin packing completed. If you need any help, obviously come see me, but you can just do a few more questions if needed.